Hello? Hello, everybody. This talk is on Multitenant Storm as a service, what we've been doing at Yahoo. So it kind of fits in nicely with some of the stuff that was here previously about Hummingbird and whatnot, but this is in the committer track, so it's going to be quite a bit more technical. I will do a brief overview of what Storm is and how it works, but I'm not going to dig very deeply into that. If you're interested, there is a Birds of a Feather session coming up later on Storm, where Taylor, who's another Storm PPMC member like me, is going to be there, and I'm happy to chat about the details of how Storm works. So, is this thing working? The clicker doesn't seem... Oh, there we go. Yes. So, hi, I'm Bobby Evans. Right now, my current title is I am the low latency data processing architect at Yahoo. Really, I'm just kind of a systems guy. I've been doing Hadoop for a number of years, but more recently I've branched off into a few other interesting things to play around with. So a lot of my day is taken up by Storm. But we also play around with Spark, which is another talk that one of my colleagues is going to be giving on Thursday at 11:50. So if you want to learn more about what we're doing there, great. But also we get to play around with a lot of fun machine learning stuff. Online machine learning, deep learning, all kinds of things like that. We are hiring, so if any of you are interested, please come see me or come see Andy. All kinds of great fun things that you can play around with too. I have a number of letters after my name, as some of my friends like to say. So I'm a PMC member for Storm, Hadoop, Spark, and Tez. For the most part, I really do just concentrate on Storm right now, but I do get to play around with the other stuff as well. So on to what we're actually going to be talking about. So at Yahoo, we've done a number of things with Storm to make it available as a service for all of Yahoo, a hosted service. So I'm going to be talking a little bit of an overview of what Storm is, what Yarn is. I'm going to talk a little bit about why we bothered to do this, and then get into some of the details of how we secured standalone Storm, some of what we've been playing around with Storm on Yarn, and what the next things are that we plan on tackling. So first of all, Storm. As it's been said a few other times, Storm is a system that processes essentially a DAG. It does real-time event processing of tuples. So it has a number of different concepts. The first one is a stream. So it's an unbounded set of tuples that are coming into your system. A spout is a source of that stream. It's where it ingests the data. So this may be Kestrel, this may be Kafka, this could be, you name it. Whatever you want to be pulling data in, Redis, whatever. Bolts are individual pieces that consume one or more streams and may produce one or more streams, 0 or more streams. So they do the processing. They can do aggregations, they can do filters, all kinds of different things. And a topology is these different pieces put together. And so when you actually want to do something interesting in the processing, you put all these different pieces together to create a topology. The architecture itself of Storm is kind of this layered architecture. You have Nimbus, which is the master node. That's where you submit topologies to. That's where you look at the status of your topologies. It decides what's going to run where. But Nimbus is stateless. It stores all of its state, or at least most of its state, in Zookeeper. And then you have the supervisors, which if you're familiar with Hadoop, is a lot like a node manager or a task tracker. They're the ones where their job is they're responsible for bringing up the actual worker processes that process the data, and then monitoring them, making sure they stay up. And then you have the worker processes. The worker processes do the real work. And so, for the most part, they're communicating with each other directly. You don't have any of the other pieces in the fast path of the data. Yarn, on the other hand, has a similar architecture, but it is slightly different. So Yarn has a resource manager that does scheduling. It decides where all the different resources are going to be. It has node managers that are responsible for actually launching and monitoring the tasks as they run, but its APIs are kind of different in that it's much more generic. So you have an app master, which corresponds to an application that's running. It communicates with the resource manager to request more resources, and then it is responsible for going off to individual node managers to go launch them. So we may come back and refer to these things later on as we talk more about Storm, securing Storm, and Storm on Yarn. So next question, why? Why did we bother to do all of this? Well, in the short term, it's given us a number of advantages. First of all, with security, we're able to be SOX compliant, which means I can now process financial data on Storm, which is kind of interesting. Why do you want to process financial data, count all the money in something that I might be dropping pennies? Well, if you're trying to predict things very, very quickly, such as budgeting, we can do that on top of Storm, get a rough estimate of where things are going to be very, very quickly, and be sure that we haven't leaked any of this financial data out to somebody who's not supposed to see it. So again, it's the same Lambda architecture that was talked about before, but we can deal with things that are sensitive. We have reduced operator overhead by having one large Storm cluster that we run, and we don't have to let everybody bring up their own Storm cluster. It's not that hard to maintain a Storm cluster, but with some things like security, it can be a bit of a pain to actually set that up. It gives us centralized knowledge about when errors happen, what types of things are bad, how do we set up Zookeeper properly so that it can scale. All kinds of different things allows us to deal with this. It lets us manage updates, and it also gives us some elasticity. So like with Storm, when you're trying to upgrade a topology, because it's real time, you want to have a handoff. And Storm doesn't let you right now upgrade a topology inline. So typically what you do is you'll bring up a new topology in parallel with the old one, but deactivated. And then you have to deactivate the old topology, activate the new topology as part of this handoff. Well, in order to do that, I have to have twice as big of a cluster as I actually would need because I have to have both running in parallel at the same time. If I'm sharing that with everybody else, I do get a bit of elasticity. I don't have to have everything sitting idle all the time. But in the long term, we plan on getting much, much more elasticity and utilization by having a large cluster that we can actually share with batch processing so that as real-time needs peak, say it's prime time, people are starting to look at Yahoo, trying to process data, we can scale up what Storm is doing, be able to respond in real time very, very quickly by stealing extra compute from batch that may not need it at that point. So going on, securing standalone Storm. This is a lovely picture of Storm and all the different pieces that talk to each other and what we did to secure them. It's a little complicated. It makes me kind of, it's difficult to see all of that. So we kind of divided it up by the different ways that the pieces communicated with each other. So there are a number of different HTTP pieces for the UI, for log serving, that we just went through and secured them with the pretty standard way. So through the authentication, just using standard Java servlet filters. For a thrift, because there are a number of different thrift APIs, Nimbus talks through thrift. And so for that, we used Kerberos, which fits very nicely with Hadoop and the rest of the ecosystem there. Zookeeper, it supports Kerberos. So for the long-running processes like Nimbus or the supervisors, those communicate with Zookeeper through Kerberos. But because we are running the worker processes, those have to be able to talk to Zookeeper as well. But we didn't really want to force a Kerberos authentication on them and forward the TGT to them. So in that case, we actually generate a secret for each of the, essentially a token for each of the topologies as they run. And then Zookeeper, we inform Zookeeper of what that token is, and it's able to authenticate the users as they come in. Also, there's some communication between the individual workers and the supervisors themselves, which goes through the local file system on the operating system. And so we had to do some work to make sure that all the file system permissions were correct to be able to deal with that. And then the workers themselves have to communicate with each other. That's where the main path is. Right now, we haven't finished securing that with SASL authentication. There are plugins to be able to encrypt the data. And so if it's data that is really, truly important to you that you need to be sure nobody else sees, then you probably want to encrypt it. But for the most part, you don't need to worry about that. But then there's also being able to communicate with lots of different external services. And that is a little bit more difficult of a problem. So we kind of punted on that and said it's up to the end user to figure out how to do that, but not totally. And we'll get more to that in a little bit. So this is the authentication piece. So going back to the original picture that we had before, you can see how kind of those different pieces fit in. You see the end user talking to the UI or through to DRPC through the HTTP auth. You can see the Nimbus is talking to the supervisors are talking to Nimbus and authenticating through Kerberos. And you can start to see how all these different pieces fit together. So that's one piece of security. So there's authentication, and then there's authorization typically. And we'll get kind of more to the authorization in a little bit. Typically, you also have to be able to authenticate with external services. So if I want to talk to a secure HDFS, I need to be able to get a delegation token from HDFS or a TGT or something to be able to prove to the name node, I am who I say I am. And so to be able to facilitate this a little bit and make it more automatic, we've added in a number of different APIs to Storm to do this behind the scenes for you. And so we added in the ability to take credentials from the gateway, from whatever node it is that you're launching Storm on, your topology on, and push them out to your topology. So that gives you the ability to go talk to the name node and get my delegation token ahead of time and push it out to each of my individual topologies. Very similar to how Hadoop runs when it's trying to run MapReduce. We've added in the ability to actually renew those tokens also on top of the name on top of Nimbus. So it fits very nicely with the same model. The big difference is that this is out of band. So I can go back, because these tokens typically for HDFS are good for a week. I get the token, it'll be good for a week. After a week, it's dead. I can't use it anymore. So what we've done is that this is out of band. Once a week, I can wake up, I can go off to the name node again, get a brand new token, push it out to my running topology. It will pick it up and will continue to run. There's also some other pieces that we are working on to be able to make this automatic. Hadoop has a few, I don't know if you call them security holes, that Uzi uses, for example, to be able to fetch HDFS delegation tokens on behalf of an end user. It allows Uzi to be this special, a very, very special kind of super user that can pretend to be other users to get these tokens. And so we have plans to essentially use that same sort of code so that when you launch your topology, you've authenticated with Nimbus, it knows who you say you are, and then by proxy, it can go off and grab all of the other credentials that you need on your behalf. So you never have to interact with that topology again as long as it's up and running. And with that as well, we've also put in some APIs to automatically do some of this for you behind the scenes. So typically, you don't want to have to modify your code to be able to inform it, these are the credentials I need, I'm going to go shove them into some data structure, ship them out to my topology. So we have a plug-in API to do that for you behind the scenes. So typically all you would do is change your command line slightly to give it a new config that says, and by the way, go ship this HDFS, ship HDFS tokens from this name node to my topology for me. And the first one that we actually did was Auto TGT, which is kind of a sledgehammer to solve this problem. It takes your TGT, if you're familiar with Kerberos at all. A TGT is a special ticket you get from the Kerberos KDC that tells you that you can then use to get tickets for other services, like HDFS or Zookeeper or whatever else. And so we'll take that TGT, and if it's a forwardable TGT, which means I can send it off to other nodes in the system, we'll ship that off for you, so that things like HBase, HDFS, and whatnot, you automatically can just communicate with. And there are some issues with renewal right now, just because Java out of the box tends to blow up when you try to renew a TGT in Java. So we're still working on that, but it does seem to be working quite well. The next piece is authorization. So I've talked a little bit about all the different ways that we're able to prove that we are who we say we are as we come up. The next piece is, how do I restrict those people when they're communicating with Storm to only be the people that are allowed? And so we put in a pluggable authentication model for primarily with Nimbus, but also with DRPC, if you're familiar with that. And we provided a few basic authorization implementations for these that are kind of role-based. So all you have to do when you're configuring these is, for the most part, say, this is the name of the headless user, the Kerberos principal that all the supervisors are going to be running as. And then it knows how to authenticate those and restrict things properly. This is who the UI is going to be running as. These are special admins that have the privilege to go off and do whatever they feel like. And then everybody else is an end user. And then along with that, it also allows you to configure your individual topologies to say who is allowed and who isn't allowed to have access to this topology. So that lets the end user themselves grant extra permissions. So going on to kind of more of the multi-tenancy piece, Hadoop has this great thing. When you run in secure mode, your processes are running as the user that launched them. And in order for us to be able to really have our code be multi-tenant, separate pieces from each other and be secure, we needed to do that too. So like all good open source engineers, we stole it. We took the Hadoop code that does this, we modified it slightly, and now Storm also can run as the user that launched it by setting that config. As an end user of Storm, you probably don't need to worry about that because it's abstracted away from you. But if you're running the cluster itself, there's just one config you'd have to set to have this functionality now. So the other piece we added in is a scheduler. So inside Storm, there is a pluggable scheduler. And it allows you to do things either to evenly there are two that come by default. There's one that evenly distributes your topologies and the workers and the processes across the entire cluster. And there's another one that allows you to have isolation. So in that, you configure it and you say, topology A will get 5 nodes within the cluster. And when it sees topology A launched, it makes sure that it gets 5 nodes and nothing else is running on those 5 nodes but topology A, which is great. But now we have authentication. I know who this end user is. And we've extended that concept to be able to say, in our multi-tenant scheduler, I'm going to configure user B has 10 nodes that they can use. And when they launch their topology, they can decide how they want to divide them up. Maybe their first topology will get 2 of those nodes, the next topology gets 3, however they feel like they want to do that. And so that allows us to be able to provide some sense of resource isolation, but also take advantage of the authentication to make it easier for end users to actually process, to use the resources how they see fit. So all of this is available now, just so you know. Out in open source Storm, there's a branch called security that we pushed up. It has all kinds of instructions on how to set it up. And I know that there have been some people on the mailing list setting up vagrant scripts so that you can start playing around with this yourself. The pull request is up there. If you want to take a look at it, kick the tires, you can do that. Hopefully, the 0.92 release of Storm is going to be coming out shortly. After that, I hope that as part of either a 0.10 or probably not a 0.93, but probably a 0.10 release, security will be merged in by that point. So that is what we did to secure Storm, standalone Storm. Another piece that we've been working on kind of as a side project is Storm on Yarn. And this gets back to much of that elasticity piece. The Storm by itself is fabulous, is wonderful, but it doesn't give you the elasticity to be able to share resources with a much larger cluster that's doing other types of processing. So if I have a spike in traffic, I can't easily take nodes out of a Hadoop cluster, put them over here so that Storm can run on them. It becomes very, very difficult. And so one of the things we've been playing around with is trying to get Storm on Yarn. And we have a very basic system set up right now. It's similar to Slider with what Arun was talking about earlier, except it is kind of more specific at this point. So when you're trying to launch a cluster, the end user will go to the Yarn Resource Manager, and they'll say, I'm trying to launch a Storm cluster. And in turn, it will launch a Storm application master. This app master is now responsible for bringing up the cluster itself. It will launch an instance of Nimbus, it will launch an instance of the UI, and then depending on how it's configured, it will go off and request resources for individual supervisors to come up and launch those supervisors as needed. One of the key pieces here is because Storm uses Zookeeper for its data storage, Zookeeper has to be up and running already externally. There is no implementation of Zookeeper right now that runs on top of Yarn, and it's going to be a real pain to try and get that in there just because of the way Zookeeper is configured with its ensemble and things. If something goes down and tries to come back up, you're hosed. There is no real way to be able to recover from that if you completely lose a Zookeeper instance on Yarn. So right now, that is one of the limitations we have. You can do all kinds of things with this at that point. I can grow my Storm cluster. I can go off and talk to the app master and tell it I need 5 more workers, and 5 more supervisors. It will go off, it will launch those supervisors, they'll come up, they'll start running, heartbeat into the system, and it will start working. They'll start being used. I can go off and talk to Nimbus, and I can tell it to launch topologies, kill topologies, play around with all of those different things. So really, for the most part, this is just launching a standalone Storm cluster on top of Yarn. There still is a ton of work that we want to do, though. There is no security on this at this point because, again, with how we've done Kerberos authentication, we need to put in some other pieces that are going to be able to do authentication with using Hadoop itself. Hadoop gives you an application token, which you can then use to be able to authenticate users coming in. We'd need to write some thrift plugins to be able to deal with that. There are some issues with recovery from the AM. Hadoop itself has a lot of assumptions in it about the processing model that you're going to use. So it assumes that you're doing batch. Even though you aren't necessarily, a lot of the assumptions that were made are batch. So things like the HDFS delegation token only being good for a week. Well, Yarn has the same thing. If I have a job that's up and running after a week, well, if something goes down, it's probably not going to come back up no matter how hard you try if it's secured. If you're running on an insecure Hadoop cluster, well, you can keep going forever. It doesn't really have those problems. But there are a number of things that the security model has that it's made assumptions about. And so with some of those things, we need to work with the Yarn community to be able to improve those so that those assumptions aren't necessarily in place anymore. This also is available now. If you go to the Yahoo GitHub page under Storm Yarn, you can pull that down, start playing with it. It works with incubating Storm. It works with 23, 2.0, 2.4. The APIs have been changing a little bit, but for the most part, it works well. So going on, here's the much more interesting piece of what's next, because there's still a ton of work to do, but a whole lot of value. And this is where, hopefully being in the committer track, we're able to find some more people who are excited by this and able to help out a bit. So what are some of these things? Well, the first thing is Nimbus HA. There's a patch out in the community to be able to do some HA work, but it very much assumes that it's going to be a hot-warm standby. With Yarn, you don't have a hot-warm standby because you don't launch a warm app master to take over. You need something to be able to make sure that certain pieces of the state that Nimbus stores locally aren't replicated dynamically, but they're replicated much more inline. Like I said before, we need to update Yarn to be able to deal with long-lived secure processes. Storm needs some work to be able to deal with ephemeral ports. So Yarn doesn't have any concept of scheduling based off of ports. But Storm right now hard codes the ports that it needs. So in order to work around that, we need Storm to be able to deal with ephemeral ports. We want to have much closer integration between Storm, the scheduler, and the AM. That to be able to have the scheduler say, I need more resources to run this topology, but what's more, I need these resources to be on this rack, or I need these resources to be this large in size. And to be able to get that integration together, we really need to start combining the AM and Nimbus together in some fun and interesting ways, which is great for, Slider becomes this great thing to be able to bootstrap stuff and get it started. But if we want that tight integration and that deep understanding of where things are, we need to be able to have those together. And then the second piece is, do we really need a supervisor if we have a node manager? If you look at those architectures between Storm and Hadoop, there are a lot of overlap, especially in the area of the supervisor and the node manager. If we can combine those two pieces together, then potentially we have something that looks a whole lot more like a native Yarn application. Possibly looking at other ways of doing security as well. Yarn has this concept of an unmanaged AM, where the AM isn't launched as part of your application. It's something that's sitting on the side. And then it starts to look potentially more like what Mesos does or what Storm natively looks like. So the way Storm is running right now, if we launch Storm on Yarn, it's going to be a single user no matter what. I'm not going to be able to distinguish different users from each other. But if I have an unmanaged AM, I can have that AM be a special user, like the proxy user that we were talking about before, to be able to go off and fetch HDFS delegation tokens. It can pretend to be other users, and as such, it can then pretend to launch other pieces, the actual workers on behalf of that end user. So you start to have something that looks very interesting there. Elasticity is a big piece. How do we design topologies so that they can grow and shrink dynamically without relaunching everything in the topology? Some things are easy to do. If I'm just doing essentially maps where everything is processed in parallel and I shuffle all the bits between each other more or less randomly, that's easy. I can add a few new ones in, load balance, and off we go. But if I'm doing a group by, say a reduce, it becomes much, much more difficult. How do I actually partition things properly so that I can migrate different pieces of live that are running from one node to another node as those resources grow? The other piece that we're actually working on right now is resource-aware scheduling. So Yarn has some concept of resource-aware scheduling. So it will look at your CPU utilization, It can look at your memory utilization and make sure that you get what you've requested. Those are all great when you're thinking about batch, because here we get back to those assumptions of batch. What happens if I want something that has a tight SLA with real-time, that's real-time? I need to be sure that I have a certain amount of bandwidth in the network that's available to me to be able to make sure that all of my tuples flow into the system properly. Yarn doesn't have any concept for that yet. We need to put that in. Storm doesn't even have any concept for that yet. We need to add that in as well. And then there's the other piece that I talked about already with the automatic fetching of delegation tokens. So, yeah, once again, we're hiring. If you see anything here you'd like, feel free to talk to me. We have lots and lots of things open, fun things. You want to do deep learning, we have that too. And now, I think I have about 9 minutes left, so if anybody has any questions. Yeah.
Basically, I'm new to this, so my question is, when a Storm runs as an yarn application, the Nimbus will be deployed on any of the worker nodes, right?
Yes.
Now, typically from the hardware perspective, worker nodes are considered as a disposable thing, like they can go down. And when Nimbus goes down, the whole Storm process will stop running, no?
No, because Nimbus itself is stateless. And so all of the state about the topologies is stored in Zookeeper. And so if Nimbus goes down, it will come right back up, and the topologies, the supervisors are none the wiser, they just keep going. There's a bit of state that is stored on the local file system for Nimbus, and that's essentially files that are too big to fit into Zookeeper, so the actual jar that you use to launch your topology. Those things need to get stored somewhere else. The easiest place to put them in the Yarn case would be in HDFS, but we need to update Nimbus itself to be able to have those APIs, a pluggable place to say, this is where I should actually be storing these files.
Got you. And then the follow-up question will be, so as you mentioned, on Yarn, when Nimbus goes down, for a process goes down, it's very difficult for them to come back up.
So in Yarn, when a process goes down, then if it's the app master, then the resource manager detects this and will respawn it. In the case of the worker processes, the other processes, then it's up to the app master to be able to detect that they went down and respawn them. But there are, again, some batch semantics associated with this. So in much earlier versions of Hadoop, if the app master went down, all of your containers that were running were shot also. Everything got wiped clean, and it would just start over from scratch. In the latest versions of 2.4, that's not necessarily the case anymore, but you have to do some configuration to make sure that that happens. And so we're moving slowly in the right direction.
Gotcha. Thank you.
It's been a while since I've been a Kerberos administrator, so things probably have changed in the past couple of years. But you said earlier that you're basically, when you find a forwardable ticket, you're automatically forwarding it to the pieces that need it. Could you use a similar functionality to take a renewable ticket and automatically renew it on a periodic basis, and thus work around the problem of whatever the configured time limit is for your ticket lifetime?
Yes, and we have code in place to do that. It's just the Java API itself. When you get a TGT out, it has this lovely renew function on it. You call that and it blows up.
Yes. Okay, thank you.
So there's some issues with that. When we figure those out, or we do what Hadoop does, because Hadoop will also renew the token for you before it submits a job or for long-running processes. But it does that by calling out to kinit. Right. And so we may have to work around those things in some way. But honestly, the Auto TGT piece was kind of the big hammer. Let's get this out the door, make something work before we go to the much more of the laser beam approach and get HDFS pieces in there and the H-based pieces and these other things.
Thank you.
question on performance. Have you found any inflection points if you have a lot of tenants per user?
It's not so much the number per user. It's the bottleneck in Storm. It's Zookeeper, because each of the supervisors are heartbeating into Zookeeper once every 5 seconds, and each of the workers are heartbeating in through Zookeeper once every 3 seconds or something of the sort. And so it quickly becomes the bottleneck. When you're running things, typically you get to about 100, 150 nodes that are fully loaded before Zookeeper falls over and can't handle anymore. There is a hidden setting in Zookeeper where you can switch it so that it doesn't actually force sync the data to disk. And because these are heartbeats, and if we lose some of them, it really doesn't matter that much. We run that way, and we're able to scale quite a bit higher, but it also comes with a bit more risk.
Thank you.
Sure.
Yeah, you had a pretty interesting diagram on the complex configuration for security. Can you comment a little bit on the network configuration? So, for example, is this just like one huge environment with a great big firewall around it? Are you firewalled in between? What did you have to do both to achieve security as well as performance goals?
Yeah, so typically what we run at with Yahoo is that we do divide the different services off from each other. So hosted Storm runs essentially on the same backplane as the Hadoop clusters. And those have a separate security domain. So if you want to be able to reach out to external services or communicate with these other systems, you have to request, get the ACLs opened up. And so we kind of have these two different layers associated with that.
Are you guys looking at software-defined networking or any sort of coming technologies to help make this setup a bit easier?
Yes, we are looking at some of those things. So we run OpenStack internally at Yahoo for some things, and are definitely looking at some of those areas. We do have some scripts and whatnot, chef recipes to start deploying these things out onto OpenStack, but those are still very preliminary at this point and are mostly just for our QE efforts. Because if you look at data locality, Storm makes a ton of sense on top of Hadoop or co-located with Hadoop if you have data in Hadoop that you're processing. So if you have HBase or something else that's your data store. A lot of times if you're processing something else and you don't interact with Hadoop, you don't want it there, you want it next to whatever's producing the data or consuming that data. And so we definitely support hosted Storm, and we want to continue doing that, but we definitely see that there is also a use case potentially for other people to spin up their own small Storm cluster.
Right. Thank you.
Hey, so I come from the AWS world, and there they have identity and access management for all the services that they host. Is there any initiative in the Hadoop world so that Storm, HBase, and everything else, on top of that, there is a separate solution just for security and credential management? You just say, I want a user who has access to these applications, and I want these hosts to have that credentials.
I believe that there is. I think there are actually two different competing implementations. I only have about 20 seconds left.
Okay.
So I know Apache Knox is one thing to look at that Hortonworks has been doing. I believe Cloudera has a competing implementation. I know that there's been a whole lot of things going on in some security branches in Hadoop, but I don't really know all the details.
Why not choose any one of them and instead just try to do everything by your own?
Well, we aren't doing everything by our own. We're going off of Kerberos. And most of these implementations, they're trying to put an abstraction layer on top of Kerberos so that you can plug in something else behind the scenes. But the reality is that it's still going off to some central system to get authentic, to prove I am who I say I am, and get some sort of a token that I can use to talk to some other service. Am I out of time, or can I take more questions?
No, sorry, we have to wrap up.
Okay, so I'll come talk to you afterwards.